Looks like stream came up quickly tonight. Had to make a little adjustment there. Alright. Welcome to episode 11. Tonight we're going to be working on RSW-10D. Hopefully we'll be able to get this up and running. I know I promise every video that I make that I'm going to try and get more than one repair in per night. I'm not even going to go there this time. We're just going to focus on this and see what happens. So I haven't done anything to this yet. It's as I received it, and I already see a few things I don't like, and we'll get into those right now. So let's get started. So here we go. I got it, took a look at it. The first thing I noticed right away, this board is a little loose. And that could just be from, the owner was just thumping this thing and enjoying it, and it just rattled loose. That happens. I do not see anything that looks like majorly burnt. Actually, that's a lie. Or a mistake. Get my little poker stick here. Right here by this resistor. Let's see if we can zoom in. Before we get too far into this, we'll do a little diagnostic detective work. Come on, camera. There we go. Look at that. It's even focusing tonight. It's hard to see on camera, but this leg of the resistor and right down in there, that is burnt and crispy and charred. No good. This is a common conduction path too. The glue here gets conductive, and this is right by the filter capacitors, so the DC supply is right here, and this resistor gets shorted through the glue. So sometimes you'll turn one of these on and you'll see it like arcing right in here. So all this glue has to go. And these caps are going to go anyway, so that's a no-brainer. I didn't see anything bad with the green guy here. So I don't see any little burn marks or holes in it yet. The two resistors do look like this board may have been modified at some point. It's hard to tell. These are for, helps if I have them on camera. These two resistors here. That's to select between 120 and 220 volts. So we'll have to check that out. The glue down in here's got to go. We'll check that out. We have some burnt glue here, so the dashboard might not be working. I found this guy. This is a factory defect. This cap was never soldered in. The top leg of the cap is just floating there on top of the pad, so it must have either fell out when it was stuffed or something happened, but I'm sure that caused some issues. But yeah, the leg of, yeah, you can see it. You can see it down in there. Look at that. It was never soldered. And you can't really blame that on Klipsch, because this is where that amp comes from. And I don't know, what else I can say about that. Certain areas of the world are not known for high quality manufacturing. They're known for cost-effective manufacturing. So that is what it is. But yeah, we have a cap that needs to be placed into the board. So let me zoom out. First thing I'm going to do on these, and I learned this the hard way a few times. When you are going to work on any of the D-style amps, always test the digital board first. And the reason is this chip right here contains all of the software that controls the amplifier. So it talks to the digital volume controller here. It talks to the LCD. It has like the programs and stuff stored on it. So it's important that this board works. I've never tried to extract the code off these chips. One of these days I'm going to get in and do it. Chances are they probably have it locked so you can't. I haven't messed around with it yet. I'd like to try. It would be nice because I have had a couple of boards where this microcontroller went bad and the whole amp is trashed at that point. I highly doubt that Klipsch would ever release the source for it, even though the code is probably very basic. But I might be able to read it off of there. So we'll save that for maybe like a tips and tricks or bonus video or something where you can just try and play around and see if we can get anything off of that. But the first thing we're going to do is we're going to power this board on. And this voltage regulator is often failed. So I'm just going to bypass the regulator and I'm going to come in it with 5 volts. So I got to get my testing screen. And my alligator clips. I keep several of these screens around, and I think this is one that I've repaired actually. The screen. No, this is a factory one, but I have a couple of these where I've actually replaced the screen. The backlight burns out on these things, but you have to have a testing screen if you're going to work on it, and you have to make sure you're plugging it into the right spot. Make sure your connectors face the right way. I have seen somebody plug this in upside down before. I know that it's keyed, but you can still jam it in the wrong way. I keep all my test leads in these little parts bags. Helps me stay organized. My area is very small. I've been confined to the closet in the basement by choice. I'm one of those people that if I'm left to have a large work area, that work area gets consumed with madness and junk. So my smaller workbench helps me stay organized. So we're gonna adjust our power supply for 5 volts. And I'm gonna try and get it as close to 5 as I can, right on the money. Helps to have an adjustable bench supply. You can use an ATX computer supply, but you're kind of limited on what you can do with it. So, alright, I got about 5 volts and 1 amp. So, I am going to clip this on a ground, and I believe this is the side you have to go to. So we will go ground, and keep an eye on the screen. And we're going to go to this leg on the voltage regulator, and the screen is lighting up. You won't be able to read it because the contrast and brightness is crazy, but it came on. I see volume. It says it's at plus 10 dB, which is all the way up. So this guy was rocking on this thing. Oh, there you go. You can see it when I twist it sideways. Come on, little screen, behave. This camera really does not like things that are lit up. But anyways, the screen's on. One of the things I'm gonna do, since it is on, is I'm gonna change all this guy's settings. We'll turn the display brightness down so everybody can see it. Power is on auto on. Auto on doesn't really work on Klipsch amps. I've covered that in my other videos. All it does is mute them. We are going to leave phase at 0. Low pass I'm going to turn to LFE, which is all the way up. EQ flat. A lot of people put it on punch. Put it on flat, at least for testing. And then we're going to take the volume. We're going to put it all the way down. Because when I plug in my test woofer, I don't want it to explode. We'll hit the OK button. I usually check this before I test it, but I found that these things need to be powered off for a little bit to save the settings. I don't know why that is, but that's just the way it is. We're going to save the music settings, overwrite the default, and we should be good to go. System info version 1.0. I think I've seen version 1.1 on a couple of these, so there's a few different software versions, but it is an RSW-10D. Alright, so we're going to power that off. And while I'm at it, I'll just check this regulator. So I'll put the voltage up to 15. Actually, I'll just put it up to 12. You don't have to go all the way up to 15. And we are going to go to this leg. And we are not getting power on. So, if you look at the screen, you'll see when I give it power, nothing. When I take the power off, it blinks. Bad voltage regulator, that's got to go. Very common on these. So, let's get this power supply cleaned up. Let's get this out of here. And I'm going to do a recap on this board. Clean it up. I'm not going to even power it on just because I know that cap is loose on there and I don't want to power it on. I don't know why I unplugged this. I don't want to power it on with that cap being loose. I'm sure it won't hurt nothing because it's spent its entire life that way, but still there's no reason to abuse it any more than it's already been abused. So as I'm getting this cleaned up, I'll think about my plan of attack. I think I'm just going to remove the power supply first. We'll worry about the input board later since we know it's savable, I guess. I don't know how else you would describe that. Somebody posted a comment in there, that's awesome. Not so good at trolling, there's nothing in my pocket. Just excited to see those capacitors. I'd feel bad for you, buddy, if you were rocking a capacitor in your pocket. I don't even have a big one that would even make anybody jealous, so I'll just let that one slide today. Alright, let's get this power supply out of here. Some of these are nice enough to have built-in kickstands. You can just use the boards to kind of let them support themselves. I'm guessing the power supply probably works. With the regulator on the amplifier board being out, usually everybody thinks the amp is bad, and it's really just the that 5-volt regulator. I know the RSW-10D, RSW-12D, and any of the D version amps suffer from that regulator failing. I don't really know why that is. Either it's just a cheap part or it's a little bit undersized for the application. These things don't draw a lot of power though. Like, I was only drawing, you know, 1/10 of an amp, so I believe those regulators are rated for 1 amp or more. It's either an amp or an amp and a half. Always check the connectors. Don't just start ripping on these things. These have those little locking tabs in them. So get your dental pick out or a pair of pliers or something to get in there and try and pop those tabs in before you yank them out. I'll get a little zoom in on those when I get these things out. They're kind of a pain to work with. They're never facing the same direction either. That drives me nuts. Just because I'm OCD. But yeah, this is one of those goofy connectors that you probably won't be able to see. And I've covered this before, but we'll do it again. Why not? And then I can take a coffee break. So right there's a little tab, and in order to pull this connector out, you got to push that tab in through the rubber. So make sure you check and see if your fast on connectors have that. It will save you much frustration. And probably some swear words too, because when you rip that connector out, it's never fun. Especially if you don't have a need to replace it, and I believe they're metric connectors, so they're like a weird size. You can probably use a 1/4 inch, but it doesn't fit the connector right. Alright, let's zoom back out. Alright. So, I think step one is going to be we're just going to pop these mains off. I'm kind of tempted to just power it up and see if I get output. No, I'm not going to do it. I'll do it after I recap it, just because it's shorted here and I don't feel like, one, I don't want to charge the caps up, and two, I don't want to deal with any shorts. Let me make sure I even have these caps. That's the next step. 680 micro, yeah, I got these. 680 at 200 volts. I think I have them. Let me double check. 560. I might be out of 680s. That's not good. $560, $560, $560. $820s. I think I am out of these caps. That sucks. Well, I might throw some thousands in there just to test it. I'm gonna have to order some caps. Or I'll look around. I might have some of these in one of my other bins or boxes. But I have a space clearly marked 680 and it is empty. I'm always out of parts that I need. It's becoming a reoccurring problem. I'll check one more spot. 1,000. Well, we'll improvise for these. We'll put some bigger ones in and I'll order the right ones. We will not make it through a full repair tonight. Never seems to fail. That's alright. I'll have to order 10 of those and I'll probably get 5 amps in that need those specific caps. Oh well, alright, let's heat up the solder sucker. See what else is bad on this thing while we're checking it out. The amp actually looks pretty good. I don't know, better than most of the ones I've seen. It's disturbing that that cap was loose from the factory. And I haven't looked at the bottom yet. The bottom usually tells you everything you need to know. I can see if anybody's been in here messing around or reworking or anything like that. Doesn't look reworked. These weirdly soldered in resistors might be factory. If they're not factory, somebody did a decent job of top soldering it to making it look like it's factory. I don't know, that's a tough one. But these are just jumpers. They're 0 ohm jumper resistors. Almost up to temp. We can check the FETs while we wait. I'm gonna guess that this thing still powers on. I have a hunch. No short there. No shorts there. I'm gonna say it's good. We can check the gate drive resistors too, but this guy might not have a gate drive resistor. Oh, yeah, they're on board. This uses one of those other control boards. Doesn't use a PDC board. This uses I don't know what the heck they call it. It's just different style control board. Alright, big caps must go. Actually, I might even clean these up and just solder them back on for testing. I can test these. They're within my range of my tester. But I'm not going to send it back with old caps on it. It's going to get new caps either way. Good or bad. These usually don't go bad, to be honest. They're just crappy quality caps, so I replace them. Lead is your best friend here. Good old-fashioned leaded solder. The solder that worked for everything before it became a health hazard. I've seen a lot of videos of people that solder on a regular basis with lead, and they have their lead levels checked and they have no problems. I don't eat the stuff or stir my coffee with it, so I think I should be okay. And I try to stay out of the fume path. Most of the flux fumes are rosin though, and I believe that's made from pine tree sap, so that should be fairly safe. Alright, number 1 came out easy. We'll actually test these, see if they're good or not. We have corrosion on both. This one's not going to come out. A little persuasion. This is how you take a cap out. Find the hard side of your screwdriver. Just give it a whack. Try not to hit it too hard because you don't want to damage the cap if you're going to try and put it back in. If you dent the cap, you can't put it back in. That's like a soft plastic handle, so it's okay to thump it. Now, on the inside here, I had some corrosion on this resistor leg and some corrosion on this resistor leg. So our controller board might be faulty. It's got some funky glue on it, and it's turning a little bit gnarly down in the bottom. I'm gonna try and pick that off. Like, this is like a rubberized stuff. I generally don't take it off, but I might pull this board just because it looks like it has early signs of glue failure. So we might do that too. I'm going to turn off the soldering station for now, and we're going to go to hot air. 120-ish C. And we'll grab our favorite chisel tip X-Acto knife and get this glue out of here. Now I'm going to leave all this over here. There's usually no problems over there. The glue, I really don't see brown glue anywhere on the primary side. It's always on the DC side, and I assume that's because these caps see some ripple current, so they probably get hot. How hot? I don't know. But hot enough to make the glue unhappy. But this stuff is super easy to get off if you heat it up. If you don't heat it up, you're going to be picking at it forever. And you can go hotter than 120°C, but it starts to smoke and it smells really bad, so I choose not to do that. But it does come off easier if you do get it a little bit hotter. I'm definitely more worried about the fumes that come out of the glue than I am about soldering fumes. Soldering fumes with a little bit of lead in them is definitely not as bad as cancer fumes coming off of unknown glue chemicals. I'll try and clean this little stand off, but I might just cut him off and put a new one in there. And you can get these things super cheap on Amazon. You get like 200 of them for 10 bucks. I'll try and clean it off though. I really need an extra set of hands. trying to stay out of the video. I know it's kind of ridiculous when I'm blocking the view, but I'm still searching for some kind of camera solution that'll allow me the right angle to get in there, so instead of having like a first person view, it's like a second person view. But I have not found anything that I like well enough to implement, so for now you're stuck with the overhead camera. There's a cap back in here. I'm not really worried about that. That cap's coming out, so I'm not being really gentle at all. I'm just ripping out from under the cap. Try not to heat your film caps. If the film caps get hot, the film caps die. You know, get it warm enough to get the glue off, but don't just sit there with the heat, if you're using heat, and bake those film caps. Got one more spot of glue back in the corner here that's going to be hard to get to. That's right by the edge of the control board that was glued in. Alright, glue is out. It looks alright, cleaned up pretty nice. Again, I'm just trying to get most of the nasty yellow stuff off, so it's still on top of this control chip. I'm kind of 50-50 on pulling that board. It really doesn't look bad. There was one little spot I didn't like, and that was, I think, oversplash from the other glue. It's a little bit on the bottom here, but it's not touching anything. And I think this is a working power supply, so if it's not broke, I'm not going to try and break it. I will make sure that there's no conduction paths. But it looks pretty good to me. I don't know. We're going to leave that in. I will clean up this one though, because I don't like that the glue is turning brown on that, so that's got to go. This cap's got to go. This glue here's got to go. You know, the extra 37 cents they could have spent just putting standoffs and screws in here would have saved them from having to glop all this glue on there. But I guess if you want to remain competitive in the market, you have to cut some corners every once in a while. Again, just be kind of gentle with the heat. We're not trying to get it too hot. We just want to get the glue softened up so we can get it out of there. But you don't want to get the glue too hot to where it starts to deteriorate, because then you can't get it off. It's best when it's left a little bit rubbery. You can kind of get in there and just grab it with your tweezers or pliers and kind of work it out. Dental picks are almost a must for doing this. And just be careful, you know, try not to rip anything off the board or break any of the legs, or especially in these areas where the glue is not turning brown yet. It's you know, it's going to give you a little bit of a fight to get off. We're really only interested in the areas where it could potentially short. This is generally not one of them, but I'm just cleaning it off because it's there and I'm in there. But you can see how much of a pain the new clean glue is. I mean, it puts up a pretty good fight, so if you don't have heat in there, you're really going to be struggling. If you don't have good dental picks, forget about it. Go put the amp back on the shelf until you have that stuff. You'll be screaming. I guess if I ever have to rely on cleaning amps for income and that doesn't work, I could probably use these videos as a good resume to get a job as a dental hygienist. That might be a new alternate career path for me. Daniel Sue, why did you give up on fixing your speaker? And yeah, the glue gets conductive when it turns brown, so let's see if I can find a better example here. I have my parts bin right next to me, so I might be able to find a board with some gnarly glue on it for you to show you what really happens. And of course I don't. Yeah, no good examples in the parts bin, but yeah, what happens is the glue, it starts to deteriorate as it gets hot and break down, and it turns into carbon as it breaks down, and you'll get like a little line across the edge of the glue that's blackened, and what that really is it's carbon, and it forms a circuit, so it'll connect, you know, whatever it's touching together. So yeah, glue has to go. The glue is bad. The green thermal resistor. This guy right here, that is a inrush current limiter, an ICL. That I have a printout of these somewhere. Typically they're 4 or 8 amps and 10 ohms. But if you get a surge or a spike, these things almost always get taken out. So yeah, remove the glue and always check those. That's a known failure point. And while I'm heating up my solder sucker here, I will show you some of those. Actually, let me see if I can find the printout. That's not it. I'll post it in the description. I have a printout that shows what values are commonly used in these. And here's my little collection of them. So this is one of the most common. It's 4 ohms and 8 amps. And the second most common that I use is 10 ohms and 4 amps. So Klipsch primarily uses one or the other depending on what model you have. And these are Epicos, EPCOS. I think Burns makes them too. You can get them on DigiKey, Mauser. You know, any electronic supplier is going to have them. Inrush current limiters. But that's definitely a known failure point. So if you're working on your amp, make sure you check that out. All right, let's get this cap out. I'll pull the other caps out. And hopefully get this power supply powered up. It's almost like cheating having one of these solder suckers, though. It does make it so easy. When I first started out, I had one of those pen things that you had to like load up every time, and they work alright, but it's nice just being able to push a button. Something would trigger that point. Yeah. What can cause those to fail is if you have a short on your FETs that drive the circuit. If your FETs short out, you're going to get a large current spike going through, and that'll usually take out your inrush limiter, because it's the circuit's trying to source a ton of current, and it especially happens if you're blowing fuses on the amp, and somebody, like, if the amp calls for a 4 amp fuse and you put a 10 amp fuse in there, I can almost guarantee that the green thing is gone. And I get countless amps sent in that the fuses are not the right values. I guess it's a pretty common reaction, like the unit won't power on and it's blowing fuses, so if a 4 amp fuse doesn't work, maybe a 10 amp fuse will, but it actually does more damage than good. I don't really care about this cap, so I'm just going to rip them out if I can. I have plenty of those. Alright, we can see the factory cap that was left unsoldered a little better. Let's zoom in. Oh, that's zooming out. Wrong way. You can see my disaster desk that I need to clean up this weekend. So yeah, this is a nice little factory fail right there. That guy spent his whole life probably just resting on top of the pad where it was supposed to be soldered in. I don't know how that happens, but quality control was sleeping that day. We don't look too bad down in here. Nothing's really too burnt or brown. Actually it is. And it's going to be hard to see because of the way my lighting is, but down in here on this diode, you can see the glue. I can see it a lot better than you can see it. The glue right here is starting to turn brown and black and conductive right across the legs of these diode, or this diode. And when that diode shorts, usually that'll take out the supply, because it's no longer blocking current, it's just passing everything through. So I'll get the glue out of there and we'll check that. Hopefully the power supply is still good. This side over here, I believe those are, I'll have to look. These are this board here, or this heatsink, is the voltage regulators and the diode, and this side over here is the main power switches. That's what actually drives the voltage to the amplifier boards. And it's based on the volume setting. So it's like a hybrid class D. I think it's like class G or H. Something weird like that. Voltage tracking, voltage following. This is one of the better amps I've seen, though, I will be honest. Usually The ones that I'm used to getting in are in much worse shape than this. That glue's coming out pretty easy. Power switch or voltage regulator. They'll usually be marked. If it's a switching device, they're usually marked with a Q, and if it's a voltage regulator on Klipsch, they mark them with a U. So these two are marked U1 and U2, so I know that they're voltage regulators. And that's on the silk screen on the board. So I'm actually gonna pull this cap out and check it. And while I'm at it, I'll check our two electrolytics too to see if they're any good. We're gonna need these to get powered back up for the first time. So 650, that's usable. Again, these are junk caps. You know, both of them are within limits of being usable, so the two main caps we can still use for testing. Alright, I need to change the tip here. Not burn my fingers. Not set my desk on fire. So yeah, aside from this brown glue that's on the dashboard, everything else on this looks pretty good. Like the other common failures on these are these green resistors down here. They're usually 1 watts. Sometimes one of those will be burned out. Those are usually the auxiliary taps on the transformer, and those feed the voltage regulators. It's usually around 35 volts coming off of that. And then other than that, it's either the power supply board or the FETs. Like, this is kind of an easy one tonight so far. I know I probably just jinxed myself there, but we will find out one way or another as soon as we get this board recapped. And there's not that many on there. See, we have the 3 big ones and 7 small ones, so not too bad. So I'm going to clear the through hole that should have been populated. I don't know why leaded solder or lead-free solder just does not flow good at all. Like, even just trying to clear an empty hole, it was not doing a great job. So much better. So let's see if this guy was ruined here. So it is 250 volts and 104 with a K rating. Let's see where we're at. We're a little high on the range there. There we go. So 0.1 microfarad, this cap is still good. Film caps generally generally last a fairly long time. You really don't need to worry about replacing these as long as they're still functioning properly. And when they go, they go. They usually blow a chunk out of the side of them. And they smell terrible too when they let loose. I see the reason why this one might have not been nicely factory soldered in. They do not sit well on the board. That's how it would have to sit in the factory. So somebody didn't space these properly when they did the layout. I'm going to actually loosen up the other one and see if I can get them to fit in there a little better. At least I can say I tried to make it look nice. If they don't go back in nice, I won't hold myself personally accountable. But it looks like they will with just a little persuasion. Do I get problems with the transformer? No, not really. These transformers are generally, I think in all the amps I've ever replaced, I've only seen one bad transformer. And I think that had water damage to where there was actually water inside the windings of the coil. And after powering it on, it kind of self-destructed. I've never seen another transformer that was bad aside from that. And I have a box of transformers taken out of bad amps. I don't know what to do with them. I just save them in case I ever get another bad one, but they generally don't go bad. Alright, so we fixed those caps. It looks a little better. They're standing up straight. That's how it should have looked from the factory, but that's alright. Like I said, I'll let that one slide. So we're going to start with the main cap for the power supply control board. Now these do go bad fairly often. I think they're Junzels in these. I think they're only rated for 85C. And that's a pretty hot area on this side of the board here. They're sandwiched in between a whole bunch of stuff and they really don't get a chance to breathe. So these caps do dry out and go bad. And we will measure this one to confirm or deny that. These leads are bent, so I'm going to try and straighten them out just so I don't tear the through hole out. I don't want to do through hole repairs tonight. That's a pain. And just remember, the board's marked. Keep your polarity right when you put your replacement in there. Clean it up a little bit. This one has some, I'm going to leave the glue on the bottom of it. It's a little bit brown. It might throw off the value, so we can see what, why don't I use flux? I do sometimes, but the solder is flux cored, so generally there's enough flux in the leaded solder to dilute it and get a good flow on there, so I don't have to add extra flux. Sometimes I do. It's just, it makes a mess when you have to clean the board. When I'm doing surface mount stuff, I use a lot more flux. Alright, this is 47 microfarad. Let's see how bad or good this still is. Actually, this one still reads good, 42. I'm kind of surprised because the glue is pretty nasty on the bottom of this cap. But either way, these definitely have to go, so we will pop a new cap in there and it will be happy for a very long time. You know, another thing you can do too, and this drives me nuts, I don't know why these resistors here and it's hard to see, but why the leads on these are curved over to the side. Like, it drives me nuts. They should be straight up and down, so sometimes I'll just kind of yank on these a little bit and straighten them out. It's not, that important to do, but if it's next to another component or it's in the way, you can straighten those out and gain a little extra free space in there. Alright, here we go. Let's get these caps on. Double checking our polarities. The negatives are marked on these, and they also have the square pads for the positive legs. But always double check. I'll clip them all off after I replace them all. I think they're all going to be 47s, and I think there's two 100s. And just to show you how little flux I do use, like this is my flux tube, and I refill it from time to time, but I generally just don't use a lot of flux. I mean, I got a couple other ones. I like Chip Quick. Chip Quick and Amtech are my go-tos. They're actually for surface mount stuff, but they work pretty good for through hole as well. I like the Amtech. I think it's 559. I got mine from the Rossman store because I like watching his videos. And the price wasn't really any better or worse than you can get it anywhere else, so that's always nice. Sometimes the legs aren't too bent, you can kind of twist them out. Just be careful when you're pulling it. That one's 47 and 50 volts. I'm running fairly low on caps. I'm going to have to do another order. I know I'm low on all my big ones. I'm going to have to check my spare bins. I might have some smaller ones laying around, but I know they are depleting. I did a couple Sunfire amps, and Sunfire amps have a ton of caps in them. And 4.7 and 47 are pretty much used on everything. Try not to bend the leads too. Like, I know they do this in the factory so they can keep the parts from falling out of the board, but I've seen a lot of videos where people are repairing stuff and the first thing they do when they put a part in is just bend the leads over to make it easier to solder. Don't do it. It's terrible. It's a bad habit to get into. That's what I'll say about that. $47 and $50. I'll be interested to hear back from this guy when he gets his amp to see if it sounds any different. I have to imagine that there's going to be a noticeable difference with that film cap soldered back in properly. I'm surprised it wasn't returned for humming or having noise issues. It's kind of mind-blowing. Either that or it's in a really non-critical part of the circuit. I don't know. That's the first time I've seen that one. guy's in there a little crooked and it's going to bother me. Alright, I think we have two 100s left and two 47s. The two 100s are on the top, and I think the 47s are back by the smaller supplies. It's surprising how similar these power supply boards are. For those bigger caps, does it need to be the same value? So if you're talking these large ones, I guess the correct answer is no. They're designed to handle a certain amount of current draw from them. So you can go bigger. I wouldn't go smaller. If you go smaller, you might actually lose some response on some of your like harder hitting lower frequencies. If I wanted to, I could just put 1,000 microfarads in there and just leave it, or 850s. I think I have some 850s. 820s. So the most important thing is the can size. If the diameter is the same and it's rated for, you know, the same voltage or higher, and, you know, the same value or higher, and the diameter is the same, yeah, you can put a larger cap in there. It won't hurt it. If anything, it makes it a little bit work a little less hard because it'll store more energy. But those are used for power supply filtering. I mean, they do you know, store the main energy for the amp, but they're getting replenished from the wall, and there's no, well, the only current limiting is from the inrush limiter. So you know, you can really change these around, and you're not going to hurt nothing. Going larger just makes it a little easier on, you know, whatever it's dumping the load into. I usually use the factory values, but there's no steadfast rule that says you have to do that. It's just the way I do it. Preference, I guess, or habit. It generally, to be honest, as long as these are still in good shape, you can reuse them. The main caps generally don't go bad. What goes bad on these is the glue gets under them and shorts stuff out, and then they get hot and they start to leak. But it's usually not the fault of the cap. Even these cheap caps are pretty good to use on the main supply caps. Like if I was going to skimp out and use cheap caps on one place on the amp, that's the one place I would use them, is on the main filters. These are definitely the wrong pliers for this job, but I'm too lazy to go upstairs and get the right ones right now. Maybe when I run out of coffee. Yeah, the failure depends. It's usually heat related. The heat causes the glue to kind of change, you know, from like a rubbery whatever it is to a hard material, and then as it starts to deteriorate with more heat over time, it turns that brown color and conductive. And you know, this is a hot area of the amp. The bridge gets warm because you're constantly pumping. I think these are fused for 6.3 amps. So the bridge is getting hot. You have these bleeder resistors that get hot. The inrush limiter gets hot. This control board gets hot. So you have a lot of heat concentrated in that area. So the heat causes the glue to start to change. and then it's like a chain reaction from there. So either it shorts out and damages the board, or the shorts put excessive draw on the caps, and it's almost always caused by the glue, though. The caps generally don't just go bad. I mean, every once in a while you will see one where the cap just started to leak, or had some sort of manufacturing defect, but it's generally the glue that causes most of the problems and headaches. Alright, these smaller caps is for the power out. Again, check your polarities. I've been known to put a cap in backwards. Generally, it doesn't do any damage when you do that, aside from the cap. And if you do put it in backwards, don't flip it around, throw it in the garbage and put a new one in. Because after that cap has been powered up, it's generally bad. Not always, but most of the time. Alright, 2 more 47s right by the voltage regulators, and we are going to be in business to see if this thing will turn on. Actually, no, not yet. We got to get rid of the rest of the glue. Then we'll be in business. We're close. We still have the rest of the amp to recap, but if we get the power supply going, that'll be one step in the right direction. It went a little excessive with the white thermal paste on here. It's getting literally everywhere. I hate this stuff. Alright, these two are going to be 47s. I'm getting pretty lucky with the legs on these caps. Like, the iron's actually grabbing them and twisting them into the right shape so I can just pull them out. Usually I have to use my smaller tip to do that, but these ones are working pretty good. If you have burnout traces, I'm actually I'm working on a JBL amp that's severely burned and damaged. I'm gonna do that one tomorrow, just because there's a ton of work involved in it. But he has a whole portion of the copper just gone off the board. So I ordered some copper strip, and I'm actually gonna redo the layout on the board. It's probably going to be a 3 or 4 part video, but generally I would reject a repair like this because it's just too much work, and I'm not really going to even break even on it. But for the sake of showing the process on how to do that in a video, generally, it's a throwaway amp, but if you really want to, it can still be fixed, and that's the reason I'm going to do it, just because it's It's an oddball that I don't think many people would really attempt to fix. So I'm going to go through and show the proper way to rebuild the traces on a board, and that's going to include rebuilding, like it was burned so bad there's a hole burned straight through the board. It burned through the fiberglass and everything, and it was caused by leaking capacitors. And JBL is I guess kind of known for that in this series of amps. Like they use LE-tone electrolytic capacitors in their audio output stage for a filter, and electrolytic caps fail. They should have used poly or film caps, and that part of the circuit would have lasted forever, but for whatever reason they decided they liked the sound of electrolytic caps, which I don't really understand, because one, it's a subwoofer, and two, like, you really don't get that much of a sound quality difference by changing caps in a subwoofer audio path. I mean, I don't know. It's like arguing with somebody that thinks cables make sound better or worse, based on what cables you're using. I fully disagree with that. I don't think the human ear is sensitive enough to hear small frequency shifts based on what type of copper you're using in a wire. And even more so, I don't think it matters on a subwoofer, because subwoofers just produce noise anyways. Personal opinions, so don't kill me for that one. Alright, I'm just double checking to make sure that my polarities are correct on these. And I believe they are opposing. I'm verifying that the square pads have the positives, just so I don't have any mistakes, and it appears that they do. These are in line. One of them's marked, and the other one, where it would have been marked, is underneath one of the other caps. So I'm just verifying. Quick simple verification. Now we can trim these leads. Alright, we gotta do the big boy, 470 microfarad, 200 volt. I know I have those, plenty of them, in various shapes and sizes. I have skinny ones, I have short ones, I have fat ones, I have tall ones. So I'm just going to try and match the diameter with one that I have. Either of these are perfectly acceptable replacements, even though they're highly unfocused and you can't see them that great. But the diameters are a little bit different, but it doesn't matter. As long as your pin spacing is the same on them for this application, you can use either or. They're same cap, just different series, different diameter. They're both rated for 105C. They're both LGU Nichicons. Both high quality caps. I'm going to use the one that matches the factory diameter just because that's what I'm accustomed to doing. Personal preference is all that is. Definitely make sure you get the polarity correct though. The negative is marked on the board, and it is going to be the round pad. And they actually space the through holes large enough to where the cap doesn't snap in, which is kind of a Rare thing to see on a lot of these. We'll get one leg in, the cap ain't gonna go anywhere, and then we'll solder the other one in. And you can use the solder sucker or a higher powered iron to solder those in if you don't want to leave the heat on there and dance it around. I'm going to put the original mains back in. I'm going to order some properly sized 680s. Just trim some of this glue off just so it doesn't cause any problems. And if this was my amp, I would just use the thousands, but since I'm doing this for somebody, I want to return it back to factory and, you know, give them basically a restored amp to original specifications. But if it was mine, I'd put the thousands in there and call it a day. It's not going to hurt anything. And I am surprised I'm out of 680s. I thought I had more of those. I have literally everything else. I got some monsters in there. 4700s, I got 2200s, I got 3300s, 1500s. Everything but 680s, unfortunately. Again, double check the polarity, especially on the big ones. Those can sometimes go in glorious fashion if they are put in reverse. And I'm not too worried about making these look nice. I just want them for electrical connection because they will be coming back out. And I probably won't do that on video unless I do like a little tips and tricks or update video. I'll probably just pop the right ones in there and get this thing sent back out. I never really thought that I'd have so many people wanting repairs done. Like I knew I was going to get into this more as a hobby, but after I made my waiting list on my website, like, it just kind of seems like it blew up. Like, people really want their amps fixed, which is cool, and I enjoy doing this a lot, but I don't do them that often. Like, I only do, you know, one, maybe two a week, so if you're low on that waiting list, I apologize, but you're going to be waiting a while. Alright, last thing we got to do is get this glue off of it. So this is what I don't like about this. The glue is on the board and it's run all the way down to the bottom. And there's really no way I can guarantee that the glue is not going to affect this board, so this board has to come out. Luckily, it's not on the top of the board where the components are, it's just on the back, so I'm just going to pull this board really quick. I know that's an unexpected delay, but in order to do this the right way, this board has to come out. I'll feel better taking it out and clearing it out from behind there, because there's a lot of paths where this guy can short out. And I don't mind working on surface components, but they're still kind of a pain. So if I can save this board and save having to do the extra work on it, just by pulling it out now, I'm going to do it. Again, the easiest way is shake the board back and forth while you're desoldering it pin by pin. Shaking that board helps the solder from solidifying. And it allows that board to literally fall. Falls right out. Plus it's a good like forearm and finger workout. That way when you're like hanging out and somebody's like, how'd you get forearms like that? You can tell them I work on circuit boards. It can be super cool. And as you get farther down on the board, it starts to wiggle more and it becomes easier to clear these holes. And that way you don't tear any of the through holes out or any of the pads. Just kind of, it's hot. Don't burn yourself like I just did. Just kind of slowly wiggle it and pull it out. It's caught on this one bent pin, two bent pins. Pin 1 and pin 12 are bent. So we'll have to straighten those out. So you can see the glue on there. There's no way you can leave that in. All these little lines right there. Let's zoom in. So the pad on the back, this is your ground plane, this whole area. And then these are your control pins, gate drive pins, voltage reference pins. And they're all covered in glue that's somewhat conductive. And it's a lot more brown than it looks on the camera. It's like dark, crusty, nasty brown. And you can actually see, you can see when I'm scraping it, there's liquid under it. It's okay to shave these little vias flat. That ain't gonna hurt nothing. The glue will hurt though. Gotta get the glue off. Glue has to come off. I'm glad I pulled this board out. This would have been a disaster because it's, especially right here, it's getting really bad. You can see it was starting to burn through, damage the board. Covering up my coffee. I don't want to get this crap in my coffee. That would upset me. So use your pick. It's kind of brittle. I don't really need heat. Heat would help, but it's picking off pretty good just by scraping around all these pins. So again, I'm being careful. I don't want to damage any of the pins, but I'm getting the glue off, and then I'm going to take a wire brush. Take a brass wire brush, and I'm going to go over the garbage can and just brush off all the remaining residue. Just get it as clean as possible. It doesn't have to be perfect, but what we don't want is shorts. So that's what we end up with. There's a little bit of haze like right there, but that ain't gonna hurt nothing. That's good enough. Way better than it was. And then we can see down behind this coil here, this inductor where all the nasty was. So I'm gonna take my blade, zoom back out. I'm going to get down in here and just carefully kind of trim the bad glue out. Don't scrape the inductor. Don't scrape any of the parts of the coil. Just kind of get in there and get the bad glue out. And what we'll do is, when I'm finished with this amp, I'll get in there with some silicone and I'll silicone that board back in place. So it's giving me a little problem on the bottom. So I gotta bust out the heat. It helps to be a little right and left-handed. As much glue off that board as you can. And there's some traces down there, so I'm going to try and just do a scrape along the board just to get it off the traces. I don't care if it's on the inductor. That generally won't cause any failures, but down here on the traces it might, so we'll just do our best to clean it off the traces. Where does the liquid come from? The liquid comes from, I believe, moisture in the air. I think that when that material gets that dried out, I think it absorbs humidity from the air. Either that or it's part of the chemical reaction when that stuff starts to break down. I'm not sure, but moisture seems like the more reasonable reason for the liquid. That's what I would go with. Because as the rubber dries out, the rubber still wants to, you know, remain like rubber. So it's hydroscopic, I think is the word. It readily absorbs water. Alright. I'm going to clean up a little bit because we're on the last phase here. You could see all the mess from this amp. All that nasty glue. I'm actually going to clean off my mat now while I got the chance to do it. Because that should be it for the glue. Don't throw your screws away though. Those, you might need those. Alright, so we'll put the dashboard back in and we'll fire up the power supply. And I love these cheap little silicone work mats. Those things are great. They make life super easy for making messes and then cleaning them up. Make sure your dashboard goes back in the proper orientation. I should test this. I made a little tester for it out of an old amp, but I'm going to assume it's good, which is probably a mistake, but we'll go with it. See what happens. I'm going to solder in pin 1, align the board so it's in and vertical. And then I'll flip it over and do the rest. I like to work backwards after I'd done the first pin. And then again, using the thicker solder contains a lot more flux in it, so you don't need to flux these pins if you use a thicker flux cord solder. And you can see on the board, well, maybe not on camera, but there's plenty of flux residue on all of those solder joints. Of course, as I say that, I bridge two of these pins together trying to clean it up. So now I actually have to add some flux. Too funny. I don't know why, but these two pins really want to bridge together. Should have left them alone. That's what I get for being OCD on that. But I wanted nice fillets on the joints. Here's why I hate using flux though. Now I have to clean this up because there's a ton of gooey flux on there. The other ones you can really leave and not clean. I mean, generally I clean the boards anyways. I'll give them a shot of alcohol and hit them with a brush. I have a special modified paintbrush that I use to clean off all the excess residue. But if you don't use a lot of flux, especially if it's a no clean flux, you don't have to go through that process to clean all those. Well, I'm going to check this for shorts just for the heck of it. Just because I did bridge that like 47 times. Just between pins 1 and 2. And we're good. No short. So now, moment of truth. Did we fix the power supply? Everything else looks somewhat good. Now I need to locate my power cord and we can test this thing out. Power is off. And we are going to start at current limited and see what happens. Let me get my supply over here, my meter. Switch to voltage. We're on DC. I will stick the probes into the little fast on connectors here to see what we got. And we're going to go current limited on. Caps charged, and we have 8 volts. Power supply has been repaired. And it might have been good. We never tested it beforehand, but we at least know that it's still working. So phase 1 is done. Make sure our power is off. I'm going to drain the main caps on here so when I touch it I don't get nailed. Again, these probes are hooked up to a light bulb. And that light bulb just allows me to take the charge off the big caps. Where's that other big cap? This guy here. Just so there's no residual voltage floating around on that. Coffee's getting cold. It's break time. Not yet, almost. Amplifier board. Amplifier board has 2 caps on it, 3 caps on it. We're going to do those while we're in here. Just because there's only 3. And the input board, generally I usually leave those alone. I mean, I can redo it. I always change the voltage regulator on there, but I try not to I used to do everything on these boards, but I try not to mess with these. Maybe I'll do this one tonight. We'll see. But I really like to minimize any risk or damage to this board because this is the one board that I cannot fix. If that goes, if anything with that microcontroller gets messed up or goes bad or shorts out, I'm toast. We'll see. Maybe I'll do it. I think I have to pull the board out anyways to change that regulator out. At least make it a little easier to change that regulator out, so I might just bite the bullet and cap it while it's out. It's not that many caps. It won't take that long. There's nothing big on there. Again, throw lead on there. I tried to just desolder that lead free and it doesn't work. Not easily. So much easier when you do it with leaded solder. Alright, be careful pulling the caps out. The bent leads will bite you. These are non-polarized, 4.7 at 35 volts. I generally replace the caps in the amp board because the amp board gets hot. That's where the output FETs or transistors are down there, and this is where the majority of the heat comes from in the amp. That and these two heat sinks on the supply. But these heat sinks on the supply are just air cooled. This board is cooled by the back plates, so the majority of your heat is concentrated on your amp board. And heat likes to kill capacitors, so these caps are worthy of replacement. If you want to cheat and not replace caps, do it on the input board because that's the more critical board out of the two. These are all 4.7s. See, depending on what amplifier board version you have, some of these are 2.2 microfarads. The ones on this board are all 4.7s. I haven't done enough to document it. Probably should start doing that because schematics don't exist for these things, but I just kind of replace them as they go, and I don't need the schematics. And then there's always the case, like, I made a schematic for a Sunfire amplifier, and I found out that that same Sunfire amplifier has like 6 different versions, and they all use different cap values. So I had to keep looking at the speaker that or the amp that I was working on, and updating my drawings because the values were all wrong. So I just decided, forget it. I'm just going to do one at a time and replace them as I go, because every one of these is different. And you never know what version you're working on because they don't label them. Like, this could be like a Rev 5 of this board, and you would never really know. It's hard working in this corner here. I know this is hard to see too. I just don't. I need to have like a camera strapped to my forehead. Maybe I'll see if they have something like that, like a small little like first person view camera, so you could see how I do these through my eyes. That might be kind of cool. I'll have to look into that. as long as it wasn't too big or too heavy or obnoxious. And yeah, I have to pull this board out anyways, so we will pull it out and recap it. Necessary? Absolutely not, but we're gonna do it. One, because the board's already loose, and two, because I can't get to that other cap behind here. I can say with 100% certainty, though, that this board was never removed by a user. It is factory loose, if that is a thing. I'll call this the home stretch. What did I do here? I screwed something up on my screen. There we go. Lovely glue they use on these. It's like a plastic, actually, melted plastic. I don't know why they wouldn't use that on the rest of the amp board, because it does not seem to be conductive, but it sure is a pain to get its screws off with that on there. Alright, last one is by the power connector right here. And these are audio filtering caps. They're part of the high pass filters on here. Alright, last one of these, and then on to the feature board. I might leave the voltage regulator intact until I get the board back in and remounted, just so I can show an easier way on how to remove and redo that. But I know that board powers on and functions with 5 volts. We tested that earlier in the video. So, if we power it on from the main amp, or the main supply, when it's installed in the amp, and we don't get anything out of the display, we know what the problem is. Alright, leave that there. Let's go to this guy. So there's not a whole... These are actually straight soldered in too, so this won't be too bad. We'll just run through this really fast. I can tolerate this because the caps aren't soldered weird. Now this one's glued down and bent over and soldered to a surface mount. That one's staying in. I'm not messing with it. There's really not going to be any load on that cap, so it's not going to be bad. Generally, none of these caps are going to be bad, but since we have it out, I'm just going to do it. A little extra, little bonus for this guy, since he waited so long to have me fix it. One of these days I'll get this camera moved and I'll show everyone my shelf. It's just littered with amps. 50 volt, 4.7. I have so many amps to fix. I need to start really making more videos. But it's nice to be back down in here and working on these. I've been busy. I've been working on my house lately, so That's I guess a priority, and work's been kind of kicking my ass lately too, so that is where my time has been focused. My house and my regular job. I wish this was my regular job. It would be a lot more fun. I don't think it would pay the bills, but it would still be more fun. Maybe if I get 5 million subscribers, it'll pay the bills. I don't think there's 5 million people that are interested in amplifier repairs though, so my hopes won't be too high for that. Now this board does have the capacitor on it that controls the on-off circuit. So if you're having issues with the auto on-off feature, recapping this board will solve that problem. As I say in probably all my videos or all my descriptions, don't rely on the auto on-off features. When you're not using your sub, turn it off or unplug it. Like, digital switches are pretty cheap these days. Standard switches are pretty cheap. Power strips are pretty cheap. Literally anything that has a switch that can turn this thing off is not going to cost you a lot of money. But if you spend, $15 on a power strip, you won't have to spend $115 to send it to me. And actually I charge more than that, so 22 and 50 volts. I know we need 2 of those, probably 3 of them. And these are all marked. These ones are marked a little differently. This board is marked with the positive side, and they still use the square and the round pads. Now this is a board that's actually designed and made by Klipsch, I believe. Maybe not, I don't know, there's some weird symbol in the corner of this board here, maybe it's not. But, well, it might not be made by Klipsch, that might be the manufacturer, but I believe the design is a Klipsch design. That was almost bad. I almost dropped my iron and burned my hand. Coffee is in full effect right now. It's like surging through me. Alright, what do we got here? This is another 22. Now, some of these boards, oh boy, actually I'm glad I'm doing this. I found another bad solder joint. Where's my remote? This will probably be pretty hard to see. Let's check it out. Get in there, camera. Focus. Yeah, you can see it. Uh-oh. There's no solder in that joint at all. No solder. That's a factory defect. We will fix this. Yeah, I mean that's cool, Daniel. Like, I would definitely work on your board for you. This one is from Canada, actually. Pretty cool, dude. I don't remember if he found me on eBay or the forums, or I think he found me on the forums. Klipsch forums. But he said, yeah, man, he sent me out This board, actually, so I'm glad I'm recapping this, because yeah, if it's going out of country, I don't want this thing to ever fail. I want to die before this amp fails. Because like every one of these I send out, I have a warranty on, and I live up to my warranty. And exceed it in most cases, so I don't want this thing to ever come back. Nothing against that guy, but I want this amp to be so good and work so well for him that I never have to hear from him again. Unless he wants to say like, hey, how you doing? My amp still works great. Realistically though, you should, I mean, with quality caps, and if you turn these amps off, you should get probably, 20, around 20 years. 20 years I would say is a fair target for this. And sorry I was zoomed in there. I forgot to zoom back out. But yeah, a full recap with quality caps, removing the glue, and if the amp is maintained in a dry environment, it's powered off when it's not in use, I see no reason why you can't get 20 years out of one of these after it's been redone. It depends, like there's obviously things that are out of everybody's control. Power surges, lightning spikes, like things like that. I mean, you're kind of at the mercy of nature. But the main failure is leaving these things powered on. The longer they're powered on, the longer they just sit and cook themselves. This guy's got a big ground plane on him. So yeah, when these things just sit and bake, they tend to die. There's really not a whole lot you can do about that. .22 microfarad, 50 volts. We have like 3 or 4 more caps to do, and then we can fire this bad boy up and make sure it works. But yeah, I would say the most common failure for leaving a digital amp powered on is this voltage regulator just sits and cooks and dies. That's going to die before your caps do, which is probably what happened with this board. The power supply was still in fairly decent shape. It had some glue damage. I'm going to guess that it still worked, but it was on the verge of failure. But I can almost guarantee that this voltage regulator has failed, and it has failed from a thermal death. It's like leaving your car out in the sun and the paint's, eventually the paint's going to fade. Heat just slowly kills things, especially, sensitive electronics. If you have a PC and you run it with a fan that's got dust in it, well, the chances are you're probably going to melt your processor. It's not going to physically melt, but it's definitely going to, if nothing else, go into thermal throttling. This stuff is the same way. It overheats, the voltage regulator starts shutting down. It gets weak over time, and then eventually it says, you know what, I'm not working anymore. And I know a lot of techs that don't know about that voltage regulator. I mean, everybody's going to know about it now. I'm giving all my secrets away, but yeah, a lot of forums and postings that I've read about don't really ever mention the 5-volt regulator. That is a common failure point, though. And the processor gets hot too. Like you can see under the coating there that the coating has yellowed a little bit. I've never seen it cause problems, but I know it gets hot. Is there a way to test which MOS? Yeah. If you're trying to test the FETs on the board, just look for shorts. They will almost always fail in a shorted condition. So if you have two of the legs and one of them's shorted to the other, doesn't matter which two are shorted, that's going to be bad. And if you replace them, it's better to replace both of them at the same time. I mean, you can just replace one, but they're usually weakened by heat and age, so I would just replace both. These little guys get hot. I think these are 10 microfarad, 16 volts. I've had some amps when I was first starting out doing some of these, and I would just try to replace the broken parts and skirt around replacing anything else, and it usually always came around to bite me. I'd replace, the bad FET. The amp would work for 2 weeks, and then the other FET would go, or it would fail and it would take out both of them, so I'd have to buy another extra one. It's better just do them both at the same time. I know one of these is tied into this glue here. I think that's a 22, no, a 4.7. So I have two more 10s and a 4.7, so I grabbed one too many. .7. So I'll take out the two 10s. One of them soldered to this resistor. I don't know what this resistor is actually 0 ohm. It's just a jumper. It couples. Okay, so it ties the plate to ground, is what it does. There must have been a problem with routing the ground plane over to that pin, so they just put a jumper on there, and instead of putting it on the bottom of the board or the top of the board, or just using an actual jumper, they just soldered a 0 ohm resistor across the negative side of that capacitor. Whatever works, I guess. Not the way I would have done it, but I didn't design this guy. See, if I don't put solder on it, I can't get these darn things to come out. You gotta dilute it. These little guys get hot. Alright, 2 more 10s, one 4.7, and we are done. Let's see, what's our time? What did I clock in at? We're at 2 hours. I still have not become lightning fast at doing these. That's okay. I want to say I had the power supply working at like the hour 30 mark, so that counts for something. This is all like VIP customer bonus footage. Well, this guy does have to get that leg. I have not forgot about it, but what I want to do is tack it in there first, and then bend this guy back down. And I want to push it into the solder pool. Not like that though, because I just caused a short. Cheap screwdrivers. Try that again. I'm not happy with that. That's coming off. No potential shorts. That's bad. I need like a buzzer of some sort, so if I'm working off camera, somebody can like nudge it and say, hey, can't see what you're doing. I did not like how that lead bent after I tried to move it back, so I'm going to gently try to force it to have a nice spaced curve to it. So it makes contact and it's at no risk of shorting out. That's way better. It was just too close to the other leg on the capacitor. And I guess I can zoom in for this so you guys can see what the heck I'm doing. So there is a 0 ohm resistor, aka jumper, underneath this glue here that goes to the screw terminal, and it connects to the negative of this capacitor right here. And I don't know why they did it that way. They should have just did a jumper on top of the board that went from here to here. But they chose to do it this way. Maybe it was an afterthought. I don't know. But when I was putting it back into place, the legs were too close. And it was at risk of, or what I thought was at risk of shorting out the cap. And to me, that is no good. So I rebent it out of the way, resoldered it back in. Now I'm happy with that. One more cap to go, and it's reassembly time. .7, 50 volts. Now, a lot of the 4.7s, sometimes you'll see like 25 or 35 volts. I don't think you can get that anymore in the UPS series, so I almost exclusively use 4.7 microfarads at 50 volts in these small cap sizes. I remember I was looking for it, and I think some other brands had it, but I try to be brand loyal to Nichicon. I've had very good success with them, so I see no reason to deviate from using them. I know they work. I know they're good. The Bad Caps forums rate them fairly highly, so that's what I choose to use. And as I mentioned earlier when I was talking about that, you can always go up in voltage. That doesn't really hurt anything. I like to try and keep it as original as possible, but sometimes there are limitations that force me to deviate from that a little bit. This board will also be cleaned after everything's finalized. Once I get the power, I'll order those power supply caps probably tomorrow. I'll have to see what else I need, and I'll put an order in. But the feature board is, I want to say, 90%. We left our one little glued cap on there. That ain't going to cause any problems. It's going to cause more problems to try and solder it and bend it than it would to just leave it alone and forget that it was even there. And the only reason is because it's on that through-hole capacitor. And it's in the audio path. It's really not seeing much heat or much load. And quite honestly, even if that did fail, I don't think it would make really much of any difference to the to the sound or the signal. I don't know what it does. I'd have to look at a schematic of that circuit. But I don't think we're at any significant risk there, aside from damaging the board or damaging that unknown capacitor by trying to remove it. I guess I could cut it off and just take lead by lead, but it's just not worth it. There's no reward for the risk we would be taking. So we're going to try something new here today too. I made a new harness, which I cannot, yeah, here, this guy right here. So I forgot about these things, and this series of sub has like a little triangular plate in the front that has the infrared sensor and the audio inputs. Well, I don't have that board, so I'm not really worried about the infrared, but I do need an audio signal. So these are JST-XH series connectors, and I just took a good old-fashioned Radio Shack RCA with double outputs and wired it up in there. So I'll add this to my little plugs and harnesses and junk. I am going to screw this board down because it's going to go back in the box for a few days while I wait for those new caps to come in. But hopefully it will work. And I could send the guy an email and say, hey, your amp's working, I just got to get 2 more caps because I didn't stock my parts bins and I was out of them. I think we'll do this one through the cheap oscilloscope, and since it is 2 in the morning, I will go to the resistors instead of a speaker. So we'll dump it into a silent load. That way I will not get killed when I go upstairs. It'll be interesting too. I've never tested out my little audio connector. I'm sure it's going to work, but it's still cool because I just made it the other night after looking at this and realizing, oh crap, I don't have a way to get the audio signal in. And since there's no schematics, I had to kind of reverse engineer that a little bit, so that was kind of fun. Wow. I do not like that. So I don't know if you can see that, but that board is warped in there pretty bad. And that's not my fault. That is Chinese manufacturing's fault. But I'm going to try and correct it. And we're going to correct that by we're going to cut off that standoff, try to rip it out of there, and I'll put a new standoff in. What happened was there's a quarter of an inch of, or not a quarter, but like a 1/16 of an inch of glue on the bottom of the standoff, blocking the board from sitting flat. So we will put a new standoff in there. Actually, let's do that right now. Hopefully I can find them fairly easily. Alright, new standoff, which I cannot reach. Let's grab some crimpers, that'll work. Get in there. Alright, that should be a little better. I heard it snap in, so yeah, that should help the board sit a little bit flatter. Probably wouldn't have hurt it, but I don't know. If I can fix the problem and make it better, why not? It's a 10-cent standoff. At the expense of saving a board from being warped when it doesn't have to be. Daniel asks, I reckon if I could cheat to not buy the inline current. Yeah, you can. If you want to just do a test on your power supply, you absolutely can bypass the green thing. Just put a piece of wire going across it. It would help if you'd used a current limited supply to do that by putting a light bulb in series with the power line. You don't have to, but that'll soften the blow going to the amp a little bit. Because when you plug this thing in, these two caps right here want to charge up, and there's really nothing slowing down these from charging. So when you give that power, these caps just there's a large current spike. If you don't have a slow blow fuse, it will blow the fuse. So what this guy does is it allows these things to charge a little bit slower, so it takes the initial hit out. You can bypass it though for testing. I really don't think you'll have any problems. Alright, we'll connect our amp up. Amp board is in. Connect our power going to that amp board. make sure, you know, if you take your amp apart, get your power, your ribbon cables, you know, correct. I didn't do anything. I left the zip tie on, so I know there's no problem with them, but you don't want to get these ribbon cables swapped. Pay attention to how those go. Alright, let's get my screen back out. My function generator is already set at 55 Hertz, my cheap Amazon function generator, which I love because it's actually quite nice for, I think, the $11 or $12 I paid for it. So that's ready to go. We'll get my little hacked Quimot oscilloscope. This thing's great for testing too. Plus I love that it runs on batteries. You can't beat that. It's a battery-powered miniature oscilloscope. How could you beat that? And we need audio outputs, which are on this side. I already checked the resistors. The output resistors, they're not burnt or blown. If they were burnt, I would replace them. I see that my buddy has left part of his connector on here. I'll have to send him a couple of fast-ons. Make a note. He didn't push the indentation in when he was pulling the speaker leads, so he is down a fast-on. Perfect example of why you got to push those little indentations in. Alright, let's take our load. And I always regret insulating the terminals on this. Actually, I need to shut my irons off so I don't burn out the tips. We will hook up my fake speaker. I'm surprised how loose that one is. That's no good. I need my pliers to the rescue. Or my crimpers, one of the two. Much better. Alright, I need to hook up the output of the scope and then we will be good to test. And since we're looking at sine waves, it really doesn't matter how I connect them. One of these days I will invest the time to make that a little bit better. Alright, power cord, power is still off. Connect our line and our neutral. Connect our little hacked input here. And we will give it an audio signal. 55 Hertz. Alright, hopefully nothing blows up. Let's see what happens. Again, the screen might not turn on, so keep that in mind. Let's go current limited. It's taking juice, but we have no display, which I figured would happen. So watch what happens. I'm going to flip the power off. It's going to blink. Boop. Okay, well, we knew that was going to happen. I predicted it. I used my telekinetic magic powers and I said, you know what, this is not going to work. And I will show you why. Alright, let's disconnect mains. Make sure the power is off. And I will show you the problem. And the problem is this guy right here. This is how you change this part. Let's see if I can get some light in here to make this a little bit easier to see. And I'll zoom in too. Get way in on it. so I can block the camera and you won't be able to see it. Alright, step one is getting the leads off without tearing the pads off. That's step one. So I'm going to take the razor blade and we're going to go one at a time. And we're using some force. And just kind of wobbling it on these legs. These legs are kind of thick. There's one. Try not to mess up your newly replaced cap. There's two. So I cut two of the legs off. Now I'm going to take my soldering iron. I'm going to get a blob of solder on the top of this device. Big blob. And I'm just going to let it sit there and cook. This is a huge ground plane, so you got to give it some time to let the heat get in there. And then it comes right off. So yeah, there it is. Oop, gone. Alright. There. Somebody wanted me to use solder wick before. So actually no, I'm not doing it. I'm making everybody wait the extra 2 minutes to heat up my solder sucker. I'll go through too much wick and that's not cheap. But that is the reason why you get the single flash on the LCD screen is your 5-volt regulator's gone. And if you're going to replace that 5-volt regulator, I'm going to tell you right now, you make sure you replace your caps and everything else. Don't just replace that and say, oh yeah, my amp is fixed. Do it the right way. Fix the whole thing. Don't just fix that. I keep these in stock. I got a whole baggie of them. And we'll just verify it's the right part. 7805. Which it is. These ones are made by ST Micro. I don't know what the original ones are. I think the originals were... The original ones are H dot, whatever that means. Junk. That's what that means. Cheap. ST Micro makes good parts. So we're going to remove the two legs as well. Give them a little lead. We don't want that to go in the solder sucker though. On it, good. In it, no. It'll clog my tip and I'll never get it out of there. Alright. Voltage regulator going back on. I'm going to get rid of this light. Because it's kind of blinding me. And what I'm going to do to remount this is I am going to tin the pad that's closest to the capacitor, because that's going to be the hardest one to solder. And I'm going to drop this guy down on there. And this is a surface mount part. It's a big one, but it's still surface mount. So line it up as best you can. Heat up that pad and drop it on there. Then I like to push on the device, heat up that pad, and make sure it's flat. And it's going to get hot. Don't leave your finger on there too long, you'll burn yourself. You know, try and square it up as best you can on that pad, because that pad is the heat sink for this device. If it's a little crooked, adjust it. Alright, then the next thing I like to do is, well, make sure it's square on the pad for one, because it's not square. A little bit more. It's okay to be a little OCD here because you want that to have the maximum heat sinking capacity. It's good enough. Alright, we're going to put a nice solder ball on that leg. We're going to do the same thing on the other one. It's okay to be a little excessive here because we want as much heat sinking out of this device as possible. Now for the top, I'm just going to run the iron along the top part of the heat sink. And you're going to wait till it wicks underneath. And you'll see it gets sucked under the device. And that is it. If you wanted to, you can flux it a little more, but it's on there. It ain't going anywhere. So let's clean up again and do a retest. Put my custom kickstand away. Zoom out so everybody can see what the heck's going on here. Oops, wrong way. Wrong button. Clean up my solder so I don't spark anything. Throw away the old regulator because it's junk. And let's make this amp do what it was meant to do. Alright, LCD is in. Our little monitor for our audio output, we'll boot it up. I could zoom in a little bit more. Alright, good enough. We need audio. Audio is in. And we need power. Line and neutral. Now there's a good chance that this thing is going to be set to some crazy high power level. We might have to disconnect one of our speaker leads, but we're going to start current limited. Always start current limited, just to be safe. Look at that. It booted up. It booted up. Alright, we're at negative 32 dB, which is good. Our light bulb is glowing a little bit, which means this bad boy's putting out some power. And let's see if we can get our... There's our audio. It's going into a 4 ohm load. I can turn the volume up. You can see the volume going up and down. I can't go too high because the power supply is going to clip. Actually, what I can do is I can go to full power mode. There we go. With the flip of a switch, we have unlimited capacity. Let's get that centered on our meter here. See if we can trigger that to keep our waves stable. There we go. Alright, so yeah, you can see that as my volume increases, the amplitude is increasing. Yeah, I can change my frequency. We'll go up to 100 hertz. 97, 900 hertz. There's 100 hertz, then we'll crank it down. 40 hertz, 30 hertz. I mean, you're going to get a little bit of a gain increase as you go down in the frequency. We'll just keep it at 40 so it stays on the screen and I don't have to readjust it. And I'm checking the heat on my resistors, making sure they're not getting too hot. Because this is a 4 ohm load. This amp doesn't really originally power a 4 ohm load. I think it's a 8 ohm woofer in there. But it's working. We're good. It's good. I'm going to leave it on a little bit. Let it crank up the volume a little bit. I can feel my resistors starting to get hot. They're 300. That's a 300 watt rated load, so you know these things are putting some power in there. Check the amp. Don't touch more than one thing at a time when you're checking the amp. It's nuts. You should actually have like a nitrile glove on when doing this. But I'm just making sure that nothing is getting too hot too quick. My load is though. It's putting on some power. How do I clean my solder sucker? It's really easy. Like, watch this. I pull this little cartridge out. I dump out what's in there. And then I put it back in and hit this button. Boop, done. It's like loading a magazine in a rifle. Pretty cool. And then these little tubes, they have a little filter on the bottom of them. And every once in a while you just got to replace that filter. I usually repack mine with just regular like fiberglass insulation. It works just fine. One of the best tools to have. And I actually have a another one. Since you asked, I'm going to show you. This one right here is the Hakko version, and this one's pretty cool. I like this, but the problem is the station that has the built-in vacuum is like $2,000, and I don't want to pay $2,000 for it. I have the module to power it, so what I plan on doing is when my Weller dies, I will figure out the pinouts in this connector, and I will hack this to work with my Weller as long as the vacuum pump still works. But I like this one because it's a pistol grip and it's really small. And it has this handle thing that's removable, which is kind of cool. I can use it. You can use it just as like a handheld pen. So pretty cool, but it's just kind of expensive to buy the base station for this. Now I could just run this and use the heat from my existing soldering station, but I need a source for the vacuum, and I want the vacuum to be triggered when I pull the trigger, so I just don't run this. I use the Weller. The Weller works. This is like my backup. I do have a kind of a hacked way that I can make that run if I need to in a pinch, but generally I just use the Weller. The Weller's served me good for a couple of years now, and hopefully it's not going to die anytime soon. So let's check back on our amp. We're at negative 20 dB. My 300 watt load is extremely hot right now. It's burning my hand when I'm touching it, and the amp is pretty much cool as a cucumber. Well, no, the output supply is getting a little warm. Not excessive, but warm. We are good. So I'm going to turn the volume down. I like to send it back at, between 26 and 32 dB. That way when whoever's installing it back in their system powers it up, it doesn't blow their face off. Nobody wants to get hit with like a, 30 hertz audio wave at maximum volume when you're plugging it in. It would scare the hell out of you. So I turn the volumes down just as a courtesy. But this amp is done, so I got to replace the two main caps. I got to order those, and other than that, I'm just going to clean the flux residue off this board, and it'll be ready to go back to the owner. So I appreciate you guys tuning in tonight. I'm going to be back on definitely tomorrow. I have one or two boards I want to get to. I'm probably going to work on one in the morning and then another one again at night. I think I'm going to call it quits here. Yeah, it's almost 3 a.m., so yeah, I'm going to call it quits here tonight and go play with my 3D printer a little bit and then probably go to bed. So I appreciate you guys tuning in. Just remember to like and subscribe, and let me know if I helped you out in the comment section with one of the repairs that you're working on. You guys have a good night, and we'll see you for the next video. Thanks for tuning in.